So this is sodium hydroxide. Solution B is 0.10 molar of in it, and that is an example is HCl. I'm not saying that solution B is HCl, but HCl is an example of a monobasic acid, hydrochloric acid. Procedure is going to be which solution is reacting, what is the volume of the first reactant, and what is the volume of the second. So those are the things. It is from monobasic acid, which is a monobasic acid B. Fill the purate with aqueous sodium hydroxide. So sodium acid, the mole ratio is. We repeat the titration and complete the table. So we are going to fill the table with, we will use 11.9. It's important like that so that to avoid, my last one was 11.9. So when you let it be consistent, if you vary the decimals, you will lose the marks. Then make sure you subtract this one. This arithmetic is done correctly. So let's calculate the average. We need to know the volume. The average we have titrated, and the volume in each titration is this one. Therefore, plus 12.0. Just press, write your number of moles of monobasic acid, solution B. So what information that will help us to calculate the number of moles of the monobasic acid? So let's go back to the procedure. We go back to, what does that mean? It means that the 0.1 molar, this is the number of moles in 1,000 centimeters cube, which is equal to 1 liter. That is what it means. So molarity, remember M stands for molarity, and the molarity is the number of moles in a liter. That is the information that is very crucial, very 0.1 centimeters cube. This is why I was telling you, you need to understand the procedure. You can go back and refer. How much volume did you use? We used 25 of solution B here. 11.93 centimeters cube of this solution will contain how many moles? The one we have stands for molarity, and the molarity is the number of moles in a liter. Therefore, 0.1 moles. These are, but how much did we use? We used 25 of solution B. So we will ask 25 centimeters cube of solution, and that one will give us 0.0025 moles. So that is the number of moles that, that is a formula that we have. Moles, molarity, volume in liters. This volume in liters, 0.1. So it is 0.1 times the volume of solution B used. The volume of solution B used is 25. So, and the answer is going to be, use this formula, and it will give you the correct answer. Calculate the concentration in mole ratio. So solution A is sodium hydroxide. This is solution A. Solution B is a monobasic. Monobasic is going to be 1 to 1. Is 1 to 1 to the number of moles of solution A. So it means that moles of A will be equal to 0.0025. Why? The ratio is 1 to 1. Therefore, if what was the volume of solution A used? Solution A contains 0.0025 moles. We will want to know, because 0.03, you can truncate for morality. For morality. Procedure 2. Using solution. Procedure 2. Using solution of hydrochloric acid, solution D at a, then continue, retain interval, add or solid interval, add or solid C and read C and star with a thermometer. Continue measuring the star with a thermometer. Continue measuring the record and recording the temperature of the mix. This is very important. You need to know if you accidentally pour down the, or you dispose the solution provided, pour down the, or you dispose the solution provided, and you have been asking, yourself. Remember, we were given released, so 20 days. Here, this is X, nothing is there. Now, at this point, we add solid C to the solution and the temperature will start rising. So, in my case, there is a trend and the accuracy. Maintain the decimal point of view. Time. Now, let's draw our graph. I have drawn the temperature against time. Now from number 20, 0, when time is 0, from here, when time is 0, you can see, when time is 0, the temperature is 23. So here, when time is 0, temperature is 20. So it is here. Again, at a half, it will repeat the same. At 1, it will start to rise. At 2, it will rise to 35. So 2. When the time will repeat 2.5, that is 37. 2.5, 37 is 35. When time is 3, that is 40. When time is same 40. And then when the time is 4, it is 3.7. So you need to know for the point to get the maximum temperature. So this one, you need to check to draw this one or this. So I will take this one. I will draw the line this and that. So you draw a complete line and then a dotted line like this. Where this dotted line meets the reference point, that is our maximum the graph was supposed to look like. So that's why I told you when the curve is has a broken X, you should know how it looks like. That's very important. Now you read at this temperature and then you subtract. So temperature change will be the initial and final, you subtract. 41. Using the graph, determine the temperature change, delta H. So our final is 40 was 23, is 24 degrees Celsius. That will be our. So I have used, when you draw like this, you show that you have used your graph to find the temperature change. The mass, this is the mass of the solution. The solution, remember, we used 50 centimeters cube. So 50 centimeters cube is the same as 50 grams give to make this 1 kilograms, because I want times T from my change in temperature. So somebody else could be the answer for that student is correct, because in practical is 3. Transfer all the solution obtained in procedure 2. Now remember the solution we have left here, we had 50, we have done it. Now the solution, we are transferring it into the volumetric flask. So the D, which reacted with solid C, right? So add distilled water to the mark and label that solution L. Remember that, because you remember solution. Fill a clean puree with solution C. Remember, solution C is HCl, though diluted. Using a pipette and a pipette fill a plain flask. So we are going to titrate solution E against solution A, which is sodium hydroxide. But we know solution E is HCl diluted, right? Titrate the sodium hydroxide with solution E using 2 drops of enough time very fast. Our table is 15.8 and the answer is 15.77. Make sure your answer is 2 decimal places for the average. Centimeters cube. Next question is calculate the number of moles. So this one is very important. So you need to remember that we had calculated. So we have that, and you must carry this one to the next question. Now procedure. So this was procedure 1, not procedure 2. Calculated the number of moles of back, and I've told you that we had already calculated the molarity of solution A. So 0.209 capital M is the number of moles of A that are present in 1000. How many moles? So this is 209 we divide by 1000, and that one will give us the number of moles, which is 0.005 of solution A that has reacted with solution E, 15.77 centimeters cube. Now we know the number of moles which is of A, but this number of moles, first we need to know the number of moles of solution that reacted with solution E. Now we need to know the number of moles of solution E. Since the ratio is 1:1, why? Because E is HCl and A is sodium hydroxide. That reaction, the ratio is 1:1. Therefore, that means the number of moles of solution A with 0.77 contains 0.005 225 moles, because the ratio is 1:1. That's very important for you to note. Now, we want to know what is the number of moles of E, of solution E, will contain how many moles? That is 250, 0.8, sorry, 0. Solution E, which is very, very important. Why are this number of moles in 250 very important? The solution